There we go. And welcome. So these recordings are usually made available after the event about next week. I usually will send out an email via Eventbrite with the link to a recording of this event. So if you have to leave early or if there is something you missed or want to come back to, those recordings will be made available to registrants. While the presentations are in session, please try to keep your microphone muted. If you have any questions, there will be a question and answer session at the end. That's supposed to stay at the end of each presentation and then at the end of the event. So after we have about 3 presentations, and after each speaker provides their presentation, we'll provide about 3 to 5 minutes for a couple questions, and feel free to put them in the chat, or you can turn on your camera and turn on your microphone and ask those questions live. That's why we host these webinars as live events, so you can have that kind of connectivity with presenters and other professionals here on the call today. Like I mentioned, please feel free to post all your questions in the chat box, especially any clarifying questions. If someone, perhaps there's a concept or a vocab word that you want some clarification on, please post that in the chat so we can have those questions answered first and have the presenters clarify that for you. If you have any specific logistical questions or challenges, please feel free to email me. I'm going to put my email in the chat as well, and my phone number is there as well, and I can help walk through any logistical challenges. So yeah, thank you for joining. A couple quick announcements regarding some upcoming guild and partner events. If you like what you see tonight, I think you'll really enjoy. We have a Built Green webinar all about examining the carbon accounting benefits of moving a house on November 9th. Built Green is an educational partner of the Northwest Eco Building Guild, and we help advocate for those events as well. And that should be a really fun education session they're hosting. That was also featured in their Built Green conference this year, if you missed out on that. And then December 7th through 8th, the USGBC is holding a summit called Bridging Occupant and Community Health. That should be a really great educational 2-day seminar. So please check that out. And then December 15th, please join us and grab a beer. We're headed to Rooftop Brewery on December 15th for a Northwest Eco Building Guild holiday party. We'll be reserving a couple tables, and Rooftop has kind of a COVID-friendly setup outdoors. Hopefully it won't be too stormy that day, but please join us for some holiday networking in person. If weather and COVID permitting, the event was kind enough to lend us a couple of tables for some holiday festivities. So please join us for that on December 15th. Should be a lot of fun. If you are interested in becoming more actively involved in informing what education topics we cover, I'd like to direct everyone, and I will also post this link in the chat, to our education event topic survey. We are still working towards getting some more feedback on what topics you'd like us to cover this next coming year. I do believe in January, we are going to be hosting a topic on landscaping during a time of climate change. But if you have topics from everything from building envelope to solar to water conservation, whatever it might be in regards to green building or planning and design, please let us know. There is an education topic survey on our website at the homepage. Please click on that and let us know what you'd like us to cover. I will also post that in the chat link here as well. And then consider becoming a member today. The Northwest Eco Building Guild has been around for many, many years and provides member benefits such as event replays and discussion forums. It provides a code innovations database. It also provides networking opportunities and to be featured on our Green Pages listing. So we provide that resource for anyone looking for a contractor or a builder or an architect for specific projects pertaining to green building. If you become a member, we'll list you on our green pages listing, as well as support you in your endeavors. And also, it's just a wonderful network of folks working towards building better, building our communities more sustainably sound. And the innovations, and especially from building code to energy code, is quite incredible and wonderful to share in our network. So please consider becoming a member today. I'll be posting our membership link in the chat as well. For those of you, the chat is located at the bottom of your screen. It's going to be labeled chat and in a little chat bubble, just in case if you couldn't find that. I know we're in a COVID world, so I'm sure most of you are used to Zoom by now. But again, if you have any questions, I'll be posting my email in the chat as well. Well, without further ado, I'd like to introduce real quick our speakers that will be speaking tonight. We are so incredibly grateful, and thank you all again so much for your involvement tonight. Thank you for joining us. Jim Ditto, we're excited to have him. He is a recent graduate of the University of Washington's Masters of Architecture and Masters of Landscape Architecture. His thesis, titled The Eighth Kingdom, is about re-envisioning building and the built environment through a biological and biometric lens. And he is now the owner of a residential design build business called Land, Liminal Arts and Natural Design. We are so excited to have also Michael Palethorpe, who is the manager of U.S. operations of Firewall, structural insulated rammed earth. He is also known as the Senior Dirt Jedi. Welcome, Michael. Really happy to have you. And lastly, we have Bill Bellick. He is the president of Nakamoto Forestry North America. He spent several years each in the international trade and carpentry before setting up distribution for the Nakamoto Japan Yakisugi Shosugi-ban products in North American market 6 years ago. Excited to hear more about that, Bill. In Japan, he has set up 60% market share of Yakisugi and top market share for both wood siding and flooring there as well. The Nakamoto family has been in timberland management and millwork for over 100 years and started making Yakisugi products in the early 1970s. So we're super excited to learn more from you as well tonight, Bill. So without further ado, I'm going to go ahead and pass it on to Jim. Welcome, Jim. Let me go ahead and stop sharing my screen. And yeah, I'll go ahead and let you drive.
Cool. Let me go ahead and get my screen shared with you. That one. Is that showing up now?
Yes, it is. It's not quite full screen or in presentation mode. That should work. Let's see. Yep, that looks great. Thanks.
Okay. Yeah, thank you, Nina. And thanks to the Northwest Eco Building Guild for inviting me to help put this together. You know, you guys have been fantastic, and I really enjoy getting to be here to talk to everybody. Good evening, everyone. Thank you for joining us. My name is James Ditto, but you can call me Jim. I'm just going to take a brief moment to acknowledge that I'm broadcasting from unceded Coast Salish territory, and I want to extend my gratitude to the Duwamish tribe, the traditional stewards of this beautiful place I call home. Go to realrentduwamish.org to learn how you can support them. We dedicate a percentage of profits at the end of each project, so you know that is when we make a profit. So since this is Zoom and not an in-person session, I'm going to keep my questions rhetorical and assume that everyone laughs at my one-liners, even if I don't hold for laughter. As being married has taught me, and design and construction law has made crystalline, it's important to start with this small disclaimer. What follows is based upon my understanding and my opinions on the subject of the evening. By all means, let it get you excited and curious, but just consider this to be part of a larger conversation we're all having around the subject. If that sounds too dry, you're probably new to the concept of biomimicry. You know, to you all, welcome, fellow discoverers. So I was born and raised far from where this photo was taken, back at that other mountain on the last slide. During my short 40+ years, I've been an artist, a U.S. Marine, lifelong learner, a maker, a builder, a database designer, volunteer coordinator, and more recently, an entrepreneur. My connection to the earth probably has more to do with landscaping, gardening, camping, and hunting than it does my zodiac signs. I just know that being here with you all, talking about the work we do and connecting it to the past and future of our planet is a gift I truly appreciate. I've always been fascinated by stories and by nature. The story of this image is that of humans traversing the land hand in hand, sharing food, knowledge, and a desire to survive against the odds. Thinking about how these steps remain long after the people have passed nearly gives me vertigo with the sense of passing time. To be real though, like the book Don Quixote, even this story likely had its share of toilet humor and fart jokes. I want to share a little bit of my own story, if you'll allow, to place us all in the context of deeper time, meeting here tonight. I hope you'll allow for any opinions expressed by me and just accept them as just that. They're just opinions. This context is key to understanding the power of biomimesis and biomimetic design. So from Seattle to Tanzania, let's fly to Scandinavia. I was in Copenhagen as a grad student with the UW a couple years ago. It was with Landscape Architecture Studio. And while we were there, we visited numerous firms and we're learning about how the city was planning its infrastructure for people and for water. If you don't know anything about it, I highly recommend you look into it. It's a huge upgrade from the CSOs, the combined sewage overflows and industrial outflows we tolerate here. Our waste is literally running from toilet to sea with every storm. And then, there are accidental discharges. So it's not nearly as funny as Cervantes, but maybe that's how the toilets are getting the last laugh. Towards the end of the visit to Copenhagen, we visited the Danish Architecture Museum, which had a multiple floor exhibition on the works multiple floor exhibition of works and installations by Bjarke Ingels Group, BIG. The B does not implicitly stand for biomimetic. I'm bringing them up because the sequence I was guided through, well, it began with the birth of our universe through the current day in a sequence of boards and linear timeline of events. And so as stars condensed to matter, planets formed, and life appeared here on our own. Evolution occurred, and at the midpoint on the stairway stood Bjarke Ingels, a life-size recording bearing witness to the company's place in all of space and time. I listened for about 2 minutes and walked on. So up the steps, millennia unfolded as evolution rolled along, species surviving, dying, adapting, growing, populations exploding and crashing, propelling others forward with an excess of waste and other resources left behind. I continue to think about how many of our current problems have arisen from the lack of the perspective of deeper and geological time. I mean, without clean water and clean air, which is a byproduct of the biota of this planet, we wouldn't have been gifted a habitable world to begin with. I climbed the stairs and humanity evolved alongside other large primates, and eventually our application of technology came to define the fate of the world. Now, birds and apes might use sticks as tools, but we turned the stick into a lever, and it has let us shift the weight of the world. When I wrote my thesis to complete the Masters of Architecture and Masters of Landscape Architecture at UW, I found my worldview changed by this concept of deep time, of the natural phenomena that gave rise to so many varieties of life, and a conclusion that the built environment is very much a living environment. It is full of creatures smaller than bread boxes and as big as buildings that have been birthed through the collective effort of humanity. It's hard to deny that more and more buildings and other machines are beings unto themselves. Think of the smart home, the self-driving car, and the AI-powered spaceships of tomorrow. I mean, I enjoyed watching Star Trek. So I gave the built a kingdom. Perhaps they're more of a combination of species like lichen or collaborative communities of fungi and algae. But for the sake of convenience, I offered to name this kingdom of life and called it the Archany. Whether the name catches on or not isn't really the point here, so much as the idea of life evolving into yet another form, one we've been calling the built environment. So why do I and others think this is important? Well, we're actively witnessing our planet's sixth known mass extinction. This is inarguably a result of the impacts on what we as a species, as humans, have collectively created, adapted, and or adopted for tools and culture. We made this mess. And the process by which we've gone about gaining so much destructive and creative power is regularly referred to as evolution. Cultures evolve and adapt. Tools, memes, teams, like technological memes, it's a weird thing, they adapt. Like birds adopting different nest types or different plants evolving similar characteristics far apart on the globe, the history of the world is filled with human ideas being transformed into physical and abstract tools, structures, systems, composite materials, buildings, homes, prosthetics, etc. And some of these inventions evolved from one another, while others pop up and they're just unrelated, but work pretty much the same way. The natural world is mirrored in our technological world. When we choose to see the overlap of terms and tricks applied by the rest of the biosphere and that which we refer to as human, we regain the advantage. What often goes as a given or is ignored altogether is the seminal role nature plays in teaching and inspiring us. I mean, all our sustainable technology is inspired directly from nature. And if you watch enough nature documentaries, you'll see where other species have managed many of the same feats without the power of story to guide future generations along. Which brings me to animal architecture. If you know of an example, go ahead and pop it in the chat. I'm always very curious to hear what people have seen animals build. It's incredible. I'm going to briefly run through some of my personal favorites. So did you know that some crickets build their own stereo systems? I mean, it's pretty good, right? Digging a set of openings into the ground, these tiny musicians build 2 amplification chambers and a narrower escape tunnel, which allows for their little love songs to blast from the ground without trapping them there. The thing I thought was particularly cool was how the area between the chambers and the exit tunnel was this little bulb chamber for the cricket's head. I mean, I could ask you why they made that little bulb, but I'll just tell you. That little bulb helps reduce the sound traveling back towards the cricket's head, protecting its little ear-like structures. I mean, it's brilliant, right? So looking at burrowing bees, like honeybees making honeycomb, they use their bodies as measuring devices, building to suit the types of movement and access that are needed to both construct and use the spiraling nurseries that they build underground. Now, this makes me think a little bit of terracotta roofs and how the tiles used to be made by forming the clay over the craftsperson's leg, like right over their thigh. And so like built to the shape of the being that's making it. So thinking of that human scale is powerful enough, but when you look at what bees do with it, it's pretty impressive. Now, is anyone else amazed by termite mounds? I mean, did you know that to scale, the Burj Khalifa is a fraction of the height that some termites are able to build their skyscrapers of mud? I mean, dirt, saliva, and dung represent the entirety of their bill of materials. So when you hear on the news that they might use astronaut blood, sweat, and tears to build on Mars, know that we are several million years behind the termites. A few facts for you. The shape and the height of the mound and tunnels allow air to efficiently circulate. It basically acts as a lung for the collective of the colony. It not only provides protection, but it simultaneously feeds the colony, thanks to a brilliant introduction of fungus gardens. Thermal controls, electricity-free HVAC, and a penthouse view. I mean, well, it's mostly darkness and close quarters, but it works very well for the termites. If you're interested, check out any of the 3 or more books titled Animal Architecture. It's amazing. Even some amoebas or protozoans selectively build their own tiny stone sleeping bags, a rock wall to protect their precious cells. When their multicellular cousins figured out how to grow their own walls or shells, their bodies adapted to handle forces as strong as you get on the bottom of the ocean. Whether built in sections or extruded and cured, the properties and biomimetic opportunities provided by the concepts of shell, scale, and skin are already widely in use. In the relatively distant past, people literally built homes out of mastodon tusks and skins. During the Middle Ages, most roofs were made out of sod. You know, green roofs are not a new invention. Frank Lloyd Wright spoke and wrote of designing organic architecture. Now we have the Bullitt Center drawing its inspiration and intention from a stand of Douglas fir. With the automation and AI, our buildings are going to be more than passive spaces. They'll be active characters in our lives. What happens when we think of their components as more than that, as organs that grow, support, and keep our arcany alive? Buildings have skins. Okay, there, I said it. Google provides enough evidence that the term, at least, has been widely adopted. The term shell is used in more specific instances. My interpretation of cladding is that it's all just a bunch of scales. Just think of how they're layered. Now, in my thesis, I looked at a small handful of technologies that could represent a carbon positive future for the things we call walls. So tonight we'll be hearing about rammed earth, a little bit about 3D printing, and cladding that traditionally uses heat to protect wood from fire. So Gaudi did not have a 3D printer, but he was a firm believer in using nature as a guide when it came to designing the built environment. Despite the magnificence of La Sagrada Familia, it still pales in several aspects to the termite towers on the left. The eroded and uninhabited termite mound on the left probably took 4 or 5 years to build and could have survived for thousands of years. We've got at least another 4 years for the final work on La Sagrada Familia to be completed. They broke ground in 1882, so it's quite a process. And it doesn't even have a world-class birthing center or nursery, let alone the ability to feed most of Barcelona. It will take more than mud and spit to keep it standing for the next 3 millennia. That said, they're now using CNC milling to help finish the last tower, which is drastically speeding up the time anticipated for completion. But there is a process that Gaudi used when designing all this that has since been articulated with the biomimicry spiral. So biomimicry, biomimetic design, and biomimesis are all just talking about the way species such as ours use the lessons and associations gleaned from the living world around us. Whether we're abstracting our discoveries into mechanical parts or synthesizing chemicals and compounds or bioengineering self-fertilizing cropping systems, looking at nature and learning the tricks of the trade among the survivors of the planet is at the heart of what our ancestors have always done, and we continue to do it today, at least until we don't. What biomimicry isn't is a cure-all or a guarantee that the design won't be harmful to life. Not because of anything unnatural, but merely because life can be harmful to life. That said, I think it's safe to say that all of our best options for sustainable, self-sustaining, and regenerative solutions to our problems are inherently biomimetic. If we're going to design and build a world that is supportive of life, we need to be looking at how nature does it. Then we can figure out how to do it all without sacrificing all of the comforts we've come to depend on. So I'll just let you read that quote. So what's it going to take to regain a livable range of climate extremes? During a Bioneers conference, Bioneers is like, it's a large group that gathers regularly every year, and this is the sort of thing that they talk about. During one of the conferences, Janine Benyus made this statement. I believe her point is that it's not too late to make a massive shift back towards a climate that our ancestors would recognize, back when all our environments on this planet were considered to be living. If you're new to biomimicry, you should look up Janine Benyus, first and foremost. She's got several TED Talks out there, among others, so you know, YouTube. She's credited with coining the term biomimicry, and you'll find she's a bit of a poet as well as being a biologist and just a wonderful storyteller. In her book, Biomimicry, Innovation Inspired by Nature, she gives numerous examples of how curious and creative people are finding solutions for problems throughout nature. What I found most fascinating probably was that it wasn't just the existence of the systems and the processes that equated to technology. It was the way that science and storytelling were key to designing biomimetically. Biomimetic design uses metaphor as much as it borrows chemical codes, genetic material, or puts other species to work for us. What you see here has become a classic example of space-age biomimicry. You know, that sound you hear when you're on a train entering a tunnel, that mix between a whoosh and a whomp. As the pressure outside of the train changes, well, it's more intense with bullet trains. They move so fast, they rapidly compress air as they move into tunnels. This could result in a big boom as a shock wave is formed. So similarly, if I dive into a pool of water, there's a sizable splash. Well, it's not that way for the kingfisher. Engineers in Japan back in the 90s noticed how seamlessly they enter the water at maximum velocity with barely a splash. They applied the concept to the tip of the train, allowing the air to move around it to avoid compression. No big boom. Perfect biomimetic example. So what happens when we look at the way nature deals with those abstractions of void and form? When we do more than just build a, quote, box in the air, as the famous architect described his leaky house. How has and how can biomimicry improve every single aspect of how we build where we live to suit not only how we live, but to suit what we need to live? Well, some billionaires have set their sights on the moon and distant planets. Less privileged people are looking at the dirt and seeing the accumulation of waste around us. And some of us look around and feel inspired. On my best days, I'm one of those people. Ancient wisdom and newfound knowledge are being combined with technology and production methods that require fewer fossil fuels, put hands to work, and sequester carbon. Paul Stamets has gained fame for taking what he learned in the forest and the lab and created a mycological industry, which is in the process of changing how we deal with food waste, bioremediating water or mycoremediating, building and remediating soils, feeding ourselves, medicating ourselves, clothing ourselves, and even coming to terms with death, which includes both the composting of human remains into soil, now legal in Washington state, and the use of medicinal mushrooms in psychotherapy, not necessarily legal in Washington state. If anyone is interested in myco-insulation for buildings, I'd love to chat. It's something I'm really interested in. There's a bit in my thesis on the subject. So for decades, we've had earth ships, Michael Reynolds biotexture, as it's called, building out of waste and recyclables with the intent to provide cleaner air, clean water, renewable energy, and food. Now, if stacking tires isn't your dream of rammed earth, formwork, reinforcement, and the right admixtures create a wall you don't have to hide. The beauty of locally sourced structural rammed earth is hardly a new concept, but the way it's being used and will be used in the future only has room for refinement and making the process fully circular. The layers tell the story of the earth itself, with naturally occurring and introduced pigments defining the layers of earth. I mean, I'm in love with the way this stuff looks. Now, the creation of agricultural amendments, fuels, and even biochar from agricultural and commercial waste are part of machines that have already been designed and built that are inspired by the grass eaters of the world. The names like iBison and horse, HORSE. Now, in my thesis, I managed to take a few of these brilliant biomimetic precedents and considered whether all the loops had been closed and if there was room for other processes and organisms to intervene in on our behalf. So looking here, you see where I've tried to tie into the Paul Stamets approach to mycoremediation, but then that can also be tied into growing mushrooms themselves, which can be tied into providing food for aquaponics, for your fish, and all these things can be looped together. They just get more and more complex. So I'm not the best at diagramming, but while grad school granted me the time out to reflect on all of this, I looked at the basic processes that all life goes through and tried to correlate them to our building and construction processes. And I can always go back if I need, which led to a list of organ systems, which could mimic the organs of an advanced multicellular organism in metaphorical and sometimes literal capacities. So thinking about a building having brain and nerves, thinking about that smart building that does that, thinking about just the story of the building that makes us care about it, which is part of its soul. So I apologize, I never developed an effective flowchart for the shell, scale, and skin category. There's a lot going on there, still figuring it out. But I think that this diagram for kidney on the right effectively demonstrates the way this holistic approach towards thinking about the flow of resources as a closed loop can provide just numerous benefits. And then on the left, the diagram for guts shows several different systems for processing organic matter into soil, fertilizers, fuel, food, and medicine. You know, just trying to look at these technologies that already exist, but looking at them through this organic lens, and trying to break down like, okay, so what can I integrate into this particular building, this particular landscape? Where can I take these things and provide for my community, for my family, or even just provide for the earth? And so what I'd like for all of us to leave here with is a curiosity about what kind of animal our home is. What kind of monster is a skyscraper? Is it like the BFG, the big friendly giant, or is it like Cthulhu? Does it clean up its own waste, or does it flush it into someone else's backyard? In the end, toilets would be best if they were humorous and not quite so hazardous. The stories we go on to tell about nature, the nature of where we live, changes what we see. I hope what you find is tons of inspiration in the natural world around you. So my call to action has to be this: redefine our world as alive. Our built environment is a living environment, and it is ailing. Take on the challenge of meeting or surpassing ideals represented by certifications like the Living Building Challenge. Our homes and buildings are tied to the very expensive and very wasteful life support system that centralizes energy production, access to fresh water, and handling of waste. Let's focus on getting this planet off of life support, and then we can think about getting off of this planet if we want to go explore the universe. Your clients and future generations will thank you. Thank you.
Thank you so much, Jim. That was fantastic.
Oh, thanks.
Before we move on to the next speaker, I'd love to open it up to our participants with any questions anyone has for Jim.
I know I covered a lot of stuff in that. If you want to go on the full ride, I think that I've given you guys access to my thesis.
Yes, certainly. I'll be sure in the follow-up email through Eventbrite, not only like I can provide the link to this recording, but if you'd like, Jim, I can also share the link you sent me as well with your thesis.
Yeah, go right ahead.
To our participants. That was fantastic. Yeah, I agree with Brian. I loved that spiral diagram. I'd love to use that in, in applications. That was wonderful.
I basically took the one that I got off of the Biomimicry Institute's website, which is just the common one you find, and I just it made enough sense to just apply a shell to it. It's like, oh, of course, it's a biomimetic design. That example right there, that image is biomimetic in itself.
Absolutely. Thank you so much for sharing. And I have had the wonderful privilege to also visit La Sagrada de Familia that you talked about in Spain. And they had an exhibit there talking about its connections to those spiral termite mounds. It looks like we have a question that came in real quick here from Eric. How do you think the cross-section of biomimicry in design and biophilic design can complement each other in the integrated design process?
That's a great question. They are related, but not inherently related. Just because something is biomimetic doesn't mean it's going to be biophilic. But if you look at like constructed wetlands, people are building these structures so that they can process wastewater on site, and they can be really beautiful. And they're using organisms in order to process the wastewater, right? So where you can, if you can incorporate living things into the design, it seems like there's a great opportunity there, depending on what you're designing. Can you give something a chance to do a job? Can you give it a home? Because we all live on the same planet. So I'm about to start rambling on that. Just dial it back. But yeah, I think that that's one of the big opportunities is trying to think about, one of the things that I pulled up during my thesis was the big tree in Avatar and how this was their home, but it was structural. It hosted a wide variety of life. And so if we look at our buildings, kind of like the Bullitt Center, one of the things I loved about that is the fact that they've built in into the building itself, as well as integrated into the landscape around it, these constructed wetlands in order to process their wastewater. So thinking about not just what you can build into the building that helps process things and all that, but also provides is featured so you can then see it, and so you get that biophilic response from getting to actually see the thing that's doing the work, but also looking at how the building is integrated into the landscape. I have a hard time now looking at buildings and thinking of them as this like object that just sits in the landscape. The building is integrated into the landscape. Now, it might not be really effectively integrated, but if you think about the way all these systems can spread out and look for the opportunities to look at how nature has done similar things, the root systems of trees providing habitat and all that, but then also see how you can integrate more nature into, and I use the term nature. It's using any term, semantics always is problematic, because what is nature? We are nature. Everything we do in so many ways is natural. It doesn't mean that it's beneficial for life, but we occur here naturally. So the things we do occur here naturally. I don't know, is that useful at all?
Thank you, Jim. Awesome. No, thank you. Wonderful.
Yeah, I'm a big fan of green roofs.
Likewise. Well, thank you so much again, Jim. If anyone has any other follow-up questions, we'll have time at the end of the event as well to ask our speakers questions. We'll go ahead and move on to our next speaker. Thank you again so much for that opening presentation, Jim. And was it Michael or was it Bill that is gonna kick us off next?
I think it was me, but I'm
Michael.
happy to switch if you want to go first, Bill.
No, because we're going to go conceptual, which is Jim, and then structural, which is you, Michael, and then just protecting from the elements, which is me.
Perfect. Great.
Awesome.
All right. Hi, everyone. Thanks for joining us. And my name is Michael. I live in Phoenix, Arizona, and I have a goofy Australian accent. I've got a couple of other people from our company on here too. Josh Cranoff and Megan Dillinger are on with us as well, so they may jump in and correct me on things or add to what I'm saying as we go. I told them to feel free to do that. I run the US operations of Firewall. We've been in business for about 25 years building rammed earth walls. I think we're the best on the planet at that. We build the strongest rammed earth walls on the planet. We insulate our walls and so on. I'll jump into our presentation and then, you'll get all those details. What I'm going to start with though is about Firewall, and then where we're going to, towards the end of the presentation, I'm going to move into where we're going with Firewall and our business. We're working on some prototype buildings that include a lot of biomimicry and working with nature rather than fighting nature all the time. So we'll talk a little bit about that. It's still sort of in early days of those projects. So let me just share my screen here. And hold on. Oh, hold on. All right, can you see that? Hold on, my screen just went black for some reason. There it is. Can you see that okay?
I think it's still loading on my end.
We only have about a quarter of the photo.
Yeah, it's
Oh,
like
really?
about a
All right,
quarter
hold
of
on.
it. If you want to try one more time.
Yeah,
Like-
hold on 1 second. Sorry about that.
Oh, there it went for a second. It was it was good. If you want to try it again.
I bet it's because I'm switching out. I'm using a laptop to a monitor. So hold on 1 second. Let's try
Gotcha.
one other thing. Hold on. Let's try this in a second.
No problem.
All right. What about now?
Still showing not in presentation mode. It's just showing within the thing.
That is weird. I'm looking at presentation mode, but it's not doing that problem. I'm going to try it again.
Sorry
Click
about that.
bottom right corner of the presentation icon.
Yeah.
Bottom right corner, that's the easiest.
No problem.
I'm not. I normally use Google Slides, and now I'm in PowerPoint because we made it in PowerPoint today, so I'm a little lost. Hold on, Megan, if you're on and you can share your screen, I don't know if you're allowed yet. Mina might need to allow.
Yeah, I can go ahead and make
Maybe that would be
Yeah. Or I can send you the link to the Google Slides. That's what I'm trying to do right now.
Okay, boomer.
Sorry.
No, it's okay. With
You want to try sharing, Megan?
Okay.
hopefully someday we can do these in person again. We won't have
good.
to. Yeah, and you won't have to worry about screen sharing.
Oh, here we go. Hold on.
Here.
Maybe I can do this now.
Okay. If you can't, let me know.
Let me try again. Sorry, everybody. Thanks for your patience. How about that now?
That looks great. And if you just click the present button
Yeah.
right there by share, yep.
Yep.
That should
How about
work.
that?
Yay, that looks fantastic. Thank
All
you
right,
so
good.
much, Michael.
There we go. We figured it out. Sorry for the delay. All right. So we build rammed earth walls. We're very different than other rammed earth builders, but a large part of what we're about is building as if life matters, because it actually does. I mean, life is all around us. We are part of life. You know, like Jim was saying, you know, buildings are a living environment, and you know, it actually does matter. I think how we build and how we design buildings to work with nature, to work with us, you know, and everything around us. Okay. Oh, hold on. There we go. So what makes Firewall unique? You know, we work, most architects, builders, contractors, you know, engineers even, have never worked with rammed earth before. So one of the things we're very good at and spend a lot of time doing when we work with clients is being very collaborative, and working with architects, designers, engineers, and so on to support them in working with rammed earth, because it is really quite a different approach than any other sort of traditional building material. We can add a lot of different colors to our walls. We have sort of 4 color categories, but there's a lot of variation within that. Our walls are non-toxic, and you know, we use the same amount of Portland cement in our wall as other rammed earth builders, but we get about 5 to 10 times the strength that they do, and we use less than 10% cement in our walls. Structural strength. One of the things about our company is we won't build anything less than 3,000 psi, and why that's significant is most rammed earth, in fact, all other rammed earth built by other people, comes in at around 1,000 psi. So that's a significant jump and allows us to be used in a structural sense. And then we also insulate our walls. You know, most buildings are either insulated, like a stick and stucco building, for example, or they're mass, like an adobe building, you know, as another example. And if you can combine both and you do it the right way, they can be extraordinarily, have extraordinary thermal dynamics and other qualities that you don't often get in most buildings. And then lifetime cost. Rammed earth is extremely expensive up front. So there's some thinking to do about that, and we like to look at value per square foot, whereas most people in North America are looking at price per square foot. But we want to come from value per square foot. And if you are thinking from there, the lifetime cost will make a lot of sense choosing rammed earth or sidewall. Texture and finish quality, we're very, very good at that compared to other rammed earth. Tends to be very rough. We've refined our processes to be able to give very fine finishes or varying finishes as needed. We've done just about every architectural feature out of rammed earth that you can imagine. Overhangs, fireplaces, niches, windows, etc. Connections, beam pockets, all of that is possible with rammed earth. We've also built with almost every type of formwork solution out there, like concrete formwork, and we do a lot of custom formwork solutions as well. So in terms of, forming up a wall and then placing the material in it to create our walls. Connection details are particularly important to us. We're very focused on the thermal capabilities of a building. We're very focused on the health of the inhabitants and what is, brought into that building in terms of, chemicals or toxic things, and also the things that the other things you don't see, EMFs and some of those sort of things are very important to us. So we have a lot to say about those sorts of things, depending on what clients need. We're also able to build below grade because we are a very strong product, and we don't have any issues with freeze thaw. We've built all around the world. We've built as far away as New Zealand, China, into India and Asia, and all over North America, or a fair bit of North America, mostly on the West Coast. Just in terms of the process of Firewall and rammed earth in general, it starts with prospecting, finding the right materials. We are particularly heavy on materials, and our focus is on materials because of the strengths that we achieve. So we generally, when we start a new project anywhere in the world, we will go into that area and do what's called a mixed design trip, where we'll spend about a week in the area visiting local quarries and mines and rail yards or barge yards or whatever is available in the area, sampling material, getting samples of materials, and then analyzing those materials. And again, because we don't build anything we don't build anything that's not 3,000 PSI or above. We're extremely particular about the materials we use. We need to have those materials doing that work for us to create that strength. So once we've analyzed those materials and we build test cylinders, we get them crushed to the geotechnical lab and test for strength. Then we typically build color samples and a sample wall before we go into any building of a residential or commercial building. In terms of formwork, again, we use very customized formwork a lot of the time, and we can also adapt the formwork that's out there already. So if a contractor owns a particular type of concrete formwork, we're usually able to adapt that to work with our system. Mixing and delivering and ramming. So the on-site work, once we have the formwork set up, we have an on-site mixing plant. On bigger jobs, it's a volumetric mixer, like in this picture here. I'm not sure if you can see my mouse, but I'm waving it over the big truck, the big white truck on the left-hand side of the screen. It's an on-site mixing plant. Usually has a bin for aggregates and sands, colors, cement, water, and an additive. It'll mix with, along a belt, or proportions along a belt, mixes in an auger up the back of the truck, and then dumps into a telebelt, depending on how you want your delivery system to work, but a telebelt is a very efficient system. That will run the material up to the top of the wall and then drop it down a trunk into the bottom of the wall, where there's people holding rammers, pneumatic rammers that are connected to a compressor. Generally, we use the one on the right, which has got the smaller butt on it, which is about a 3-inch butt. And they're placing that material loose in the wall, and then they ram that material in. We place in material in lifts of about 10 inches, 9 or 10 inches roughly, loose material, and it rams down to about 6 inches. And that's how we achieve those lifts running through. And we can obviously be very creative with those. We can have them very straight or wavy, or dying into each other. Any of those sorts of things are possible with that system. I've got some videos I can show. I may show them at the end if we have time, but of the whole process, but I'll do that in a minute. In terms of our wall system, so because we build at 3,000 psi or above, we can build directly off the foundation. Most other rammed earth needs a concrete stem wall off the foundation and then rammed earth above that. But we can build right off the foundation. We insulate our walls, and we have rebar in our walls, usually a rebar grid of, a 2-foot grid or a 1-foot grid or whatever is required for the structural requirements. Generally, depends on what kind of building. You can change how the wall system works, which I'll show you here in a sec, right there. So we can have, for example, our walls are at 24 inches. You have the ability to have 8 inches on the exterior, 12 inches on the inside, and then 4 inches of rigid insulation in between. Or if you're building something like a passive house, you could have 8 inches on the outside, 8 inches on the inside of rammed earth, and then 8 inches of insulation in the middle. And those are connected by interwide connectors, so it holds everything together for structural capabilities. The thinnest wall we can produce with insulation in it is 18 inches, and that would leave you with 7 inches on each side and 4 inches of insulation in the middle. Without insulation, we can get down to 7 inches wide. The reason for that is we have a 3-inch rammer butt on the bottom, and we need to be able to ram around rebar and so on in between formwork and rebar. And if you have a wall that's 7 inches wide, you'd have a stick of rebar in the middle, we're assuming, so you could ram on either side of that. In terms of standing out from the crowd, rammed earth really does. Just the visuals of rammed earth is extraordinary. I don't know if anyone here has ever seen a rammed earth building or been inside one. That they are extraordinary, and they have a different feel about them too. You probably would have noticed if you've been in one. But in terms of being climate ready, they're low maintenance. They really, in terms of sire wall anyway, I can't speak for other rammed earth so much, but sire wall is extremely low maintenance. You may just need to pressure wash the outside, if you have water staining and that sort of thing every 5 or 10 years, but other than that, there is no maintenance really, unless somebody runs into it with something like a car or whatever, then you need to, patch an area, but that doesn't happen all that much. We can produce exceptional indoor air quality. Our walls have the ability to regulate humidity. So they can take in vapor and water vapor and when it's humid, and let it out again when it's not. So we might have fluctuations of humidity outside that are, swings between 20% and 90%, for example. We might have a 1 degree or a 1% change in humidity inside, for example. We build our products with local materials. So the materials, the majority of the materials that are in our walls come from within a 100-mile radius of the building, of the site. Again, a lot of this is dependent upon the design of the building in terms of being able to regulate humidity, which you can also regulate mold in the building, or create a mold-free environment, for example. Same with passive heat distribution. It needs to be designed in. You can't just throw in a firewall and now it does it all for you. There's some design and thinking. It's got to come from a holistic perspective of the building. Long life cycle. Our walls are rated to last about 1,000 years. So that's why the lifetime cost is so good, because as most of us realize these days, most buildings are built to last about as long as your mortgage. We're a lot further along than that. Strength, we were developed in a high seismic zone, so we have no issue with we can handle seismic, different seismic zones without any trouble. We have outstanding thermal qualities to be able to create thermal envelopes that are extraordinary. You can't burn firewall, you can't flood firewall, and it's pretty well impervious to hurricanes. It's also impervious to insects, rodents, and rot. Firewall is built out of inorganic material, so it won't rot. It doesn't, a lot of building materials are organic and will rot or decay or whatever, but firewall is not like that. In terms of just some of the other things, hold on, I'm trying to get my little thing out of the way here. There we go. In terms of some of the things that stand out about our buildings, in terms of healthy materials, this is an example. This is one of the first full residences we built on Salt Spring Island in Canada. And it was for Randy Bachman and his family. You may recognize the name Bachman, and he's one of the members of a famous band. And they sing American Woman and taking care of business and that sort of stuff. They moved into their new rammed earth home with their daughter, who had chronic asthma. The kind of asthma that takes you to the doctor every month or two. And within a few months, she was able to throw away her inhaler. So kind of, extraordinary indoor air quality. She was also removed from the toxic environment that a lot of buildings these days are. So once she was removed from that, she was able to throw away her puffer. Passive house, we built the first rammed earth passive house. This is in Coeur d'Alene, Idaho, and it's quite an extraordinary building. So we have no problem building those sorts of things. In that same vein, we also built Jason McClellan's house, has firewall in it on Bainbridge Island, and he's called our walls the best wall system on the planet. This is another example of standing out and taking care of the world around us. This is a building in France, built by or designed by Foster and Partners, and all of the materials came from within 100 miles. It was built with local materials, local labor, and expressing local culture and benefiting the local community. In terms of structural strength, the Great Wall of China is rammed earth. It has no cement in it, like today's rammed earth. And, it was only 145 PSI, or it is only 145 PSI. And that's why it requires so much maintenance, and probably wouldn't, much of it would not be standing today if it didn't have that maintenance. The first firewall we ever built was a whopping 435 PSI. Which is pretty pathetic, really, but good first effort. Most other traditional rammed earth, and what I mean by traditional is other people's rammed earth, not firewall, comes in around 725 PSI, which is also not very strong. Here's sort of the last, decade and a half of some of our buildings in terms of the strengths we've achieved and some of the places we've built. So, ranging from 3,200 at the Edmonton Zoo to 6,000 or so, 6,600 in Vancouver. And then in the Seattle area, we built, the Tuanyu building was built by Skanska, but using Firewall, and we collaborated and consulted and provided quality control, training and so on for them. But the bottom 3 floors are partially Firewall, and that achieved a 7,200 PSI for those walls. And the requirement was 7,000 PSI. There's an example of that wall with the staircase hanging from it there, which I really like that photo. It's kind of cool with the staircase bolted onto it there. In terms of colors, I'll zip through this, but basically colors, we can build walls that have no color in them, no color added in them. So what you get is the color of the aggregates and sands that we use, the color of the cement, and then you can add things like white limestone tailings to brighten it up. You can use white cement instead of gray cement if you want more vibrant colors and that sort of thing. And you'll see the wall looks relatively consistent. You can see some variation in there, not a lot. And that variation in the color comes from moisture content primarily, but also the way it was rammed, curing time, and those sorts of things. We can also add color, and it's like concrete color, like Davis color, for example, is one of those colors we add. And we can do that in a single variegated sense. So that would be a single color, but varying percentages of that color throughout the wall. So it will add, you might have a 2%, a 4%, and an 8% or something that provide some movement in the color for you throughout the wall. Here's another example of that wall on the inside with a single color variegated scheme there. One of the other things to note about this photo is that the finished floor is run right up to the sire wall. With most other rammed earth, you won't be able to do that. You'd have a stem wall, you'd have a concrete stem wall below the sire wall, or below the rammed earth. So you'd run your finished floor up to that concrete stem wall, and then you'd have your rammed earth above that. So I think that's a good, really nice feature of that sire wall. And then we can do multicolor walls as well. So that's adding multiple colors throughout the wall, sort of in a random pattern or whatever's required by the designers. This is an example of one in Shanghai, China. This is another one that's pretty cool in New Zealand. Really, really great building built by the local Maori people. And it was designed to capture the local landscape. So you can see here the bottom brown color is the foreground. And then there's the inlet, the water inlet behind that. And then above that is the mountainscape, and then it trails off into the sunset. So you can get very creative with it. This is the Nimkami Desert Cultural Center, which it won the first place in the World Architecture Festival. I think it was in 2013, and it's a really beautiful building. Firewall was discovered by one of their junior architects, actually, after they weren't happy with a different finish. A junior architect brought Firewall to them, and they decided to go with us. We can play with textures on the wall. It's a bit hard to see from the photos, but we can design a wall that has a very fine finish to it, so a very smooth finish with lots of fine particles in there. Or we can design something that's quite rough, that has some aggregate showing and whatnot. We're able to play with the surface if we want to do that, if that's needed. In terms of scale, we've built everything from tiny houses to massive commercial buildings. Here's an example of a tiny cabin on Salt Spring Island in British Columbia. Then a large family home, or standard sort of family home in Paradise Valley in Arizona. Here's the History Museum in France. It's 94,000 square feet. A large portion of it is sidewall walls. And then we also built, or we didn't, but another contractor built with our support, a building in Pakistan. This is in Islamabad. This is an actual photo, by the way, not a rendering. And it's over 600,000 square feet. And this tower in the front, there's a communications tower. It's 100 feet tall. It's the tallest round-earth structure on the planet. All right, jumping into what we call a BFH. I won't use the F word, but it's the best effing house is what we're calling it for the time being. You know, what we're really, how that started was we started with, you know, Firewall, and it has some awesome capabilities. But then we started looking at, well, you know, we need to expand upon that and take into consideration partnering with other technologies to build an entire environment that people live in, not just have walls, you know. So creating that, you know, designing a living space for people, designing a space that is alive and that works with nature is sort of the concept there. And we call it the best effing house because once they're built, I think they will be. They're gonna really be a standout building that will use a lot of natural forces for things like heating and cooling, for example, use a lot of local materials, use new technologies, and use ancient technologies that are adapted for today's living environment. Joss, if you want to jump in here at all, feel free.
Yeah, I'll just add that it's not. We quickly realized it wasn't about the house. When we started going through that, it was a response to getting designed as a beauty product into a lot of commercial and residential buildings, and sometimes they'd take advantage of some of the environmental capabilities or the structural capabilities, but it was a fraction of what my father created the system to be for. So it was taking a step back, saying we're not building things that aren't like that anymore. We still consult on projects for Firewall throughout North America, but anything we build is going to represent our product and the not the product, but the vision behind it, and how that gets represented not just in the home, but in how it interacts. Really liked what Jim said, where he was talking about the biomimicry. We think of ourselves as distinct from nature, and we are a component of that natural environment. And part of that is how we interact with the nature and with each other. So having a building that supports our community is an essential component of that. And instead of criticizing the way things are done, showing something that is so appealing that people can't choose the other way.
Mm-hmm.
People can't choose the simple normal. All right, well, go ahead, Michael.
Thanks, John. Jump in whenever you want to. That's great. Yeah, so the best effing house, or the BFH, was created from, you know, looking at a lot of our experiences in the past where people were taking Firewall and using it as just one feature wall and not taking advantages of all of the aspects of Firewall. So we decided, you know, the only way we're going to actually be able to demonstrate what's possible is to build our own buildings and let people come and live in them, and, you know, live in them short-term, or, you know, short-term rentals or whatever they end up being, but allow people, it might be just, you know, tours or whatever, but allow people to actually experience those buildings that are built in their entirety from the kind of thinking we've done, the kind of design and work we've done on Firewall, but for the entire building. And so that's really where that sort of was created from, so that you know, we have a building that's not just a fancy wall. It's a building that is a, you know, a real living, breathing, you know, space to live in that's extraordinary. So some of the things that we look at, oops, sorry, I jumped over that one. There we go. You know, health, the structure, people's lifestyle, the, you know, the people, the nature, the land, you know, the things around the house, the community, those sorts of things are incorporated into a lot of those designs. And then, you know, looking from, you know, we look at a lot of different elements of the building, and we try and look at every element of the building, which, you know, that when you start digging into the different elements of a building at that level, it becomes massive. There's a massive amount of work there. And, you know, so we're looking at things like structure, nature and land, health, and it goes way beyond all of that. These are just examples. And, you know, for structure, for example, we might build a house, say in Phoenix, Arizona, that needs no mechanical heating or cooling, or is based around sacred geometries, or, you know, the house is built specifically in mind for durability and longevity, but with adaptability in mind. So to take into account the different things that the building might be used for over time, for example. Nature and land, you know, working with ancient and indigenous people and indigenous wisdoms as how they looked at land and how they treated land, where they would build, how they would live, where they would plant things, you know, and so on. You know, a lot of those sorts of aspects are taken into account with our BFH buildings.
Yeah, we don't want to present the BFH buildings as something that's a finished product at all. It's the beginning of a process, what we're considering a lifelong process, where we're researching with society, with the public, on what's the best living environment that we can create for ourselves, everything else on the planet. Yeah, everything as a whole, and that we are just a small component of that, and I'm sure we'll contradict whatever we've said on this once we come up with something better.
All right, so that sort of brings us to the end of the presentation. I know there was a lot of questions in chat which I couldn't keep up with while presenting. I'm sorry, so I'm happy to answer those now, or Joss can, either way.
We have time for a couple questions, and then yeah, maybe we can address them at the
Sure.
end of everyone's.
Yeah, sure.
So we